we are delighted to kick off the new year with a brilliant seminar coming to us from New York, where Johanna Devaney, who you can read her bio on the website with one correction. She's now an associate professor, even better. So I will not do a long introduction, but welcome, Johanna. Over to you.
Okay, well, thank you for having me here. It's always great giving a talk and a nice way to start the new year. So I'm going to share my screen. Okay. And everybody can see that, right? Okay. So today I'm going to be talking to you about a project which I've been sort of gestating for a long time. So you'll see some references going back for a while, but which I've just finally got some reasonable amount of funding from the National Science Foundation. So I'm actually just started getting going on actually implementing. So there's a lot of preliminary results that I'm showing, but I'm just getting started going. And the main goal of this project is ultimately focused on music, but the broader implications are about integrating domain knowledge into deep learning models. And so I come from a music background, but I work largely in the area of music information retrieval. My training, however, is predominantly in music theory. So I've spent a lot of time in the music theory classroom teaching people how to parse the musical surface. And so I come into this area of computational musical analysis with a lot of thoughts about how humans do the task from the pedagogical perspective. And so you'll see that underlying a lot of how I really think about my research. So the organization of the talk today is as follows. I'm going to begin by kind of laying out how I see this task of parsing musical signals. I'm going to talk a bit about modeling pedagogical knowledge, specifically encoding pedagogical knowledge for music theory textbooks. And then also how this can be augmented by extracting domain knowledge from musical performance. And then the part of the project which I'm working on now, getting off the ground, is putting this all together. And then I'm going to talk about some of the future directions and broader implications and the conclusions. I will try and keep an eye on the chat in case people have any questions of clarification. And then, of course, there'll be time at the end for questions. So to sort of orient things more broadly, I'm kind of thinking of musical style as a combination of musical material, instrumentation, production, and performance. But specifically, I'm focusing on the musical material and the performance elements. And there's two main things which I'm interested in. How can we leverage music's rich pedagogical tradition in building computational systems to model the organization of musical material? And the second is, how can we harness the domain knowledge in performances available in musical recordings? So I believe that we've got both a lot of codified information, but also we have in people performing, and particularly in skilled performance, where people have been playing their instruments for a long time, an expression of particular structural points of importance in pieces that they're expressing. And so we have a lot of expressions of domain knowledge about which parts of the musical surface are structurally important. And these would be interesting to kind of dig into in more detail, as opposed to just taking data-driven approaches or just saying we're going to have people annotate stuff and take those annotations and then using that as the basis for doing, say, structural segmentation, which is the traditional way that people do these kind of tasks in MIR. Okay. So you will notice, however, in this talk, I'm going to be looking at Western art music, which is a little bit different from a lot of the way that people work on stuff, which is more so in Western art music, in popular music in MIR. And specifically, this is because I'm really interested in looking at a body of work with a lot of pedagogy. So I'm taking the music theory pedagogy, I'm looking at the notated work that is in the IMSLP data set, the database, and then I'm also looking at all of the recordings that we have. And I'm looking at ways of integrating these with analysis, which I can get from textbooks and also from data sets and also from performance data, and seeing how by integrating these, I can actually start to develop models of parsing the musical surface into what we'll get to is essentially structurally significant and non-structurally significant notes, which I believe will be more useful than in doing tasks further on. This is a little bit different from the way that the traditional approach to these kind of tasks is done in MIR. So what you often see there is very distinct tasks, like you would have, we're going to do chord recognition. We're going to do segmentation into trying to figure out where specific segments of a song are. And all of these tasks are very different. I've kind of taken the approach that maybe we need to just go back to kind of looking at things more from the note level, because this is sort of more related to the way that people are sort of understanding things. And there is definitely a computational complexity there. But this is sort of the challenge that I'm undertaking. As I've said, this is preliminary work, and I'm interested in hearing feedback on this, particularly in the discussion section. So some of the assumptions and assertions that are underlying this, the first is that most generally, humans learn with greater efficiency with machines, in large part because they exploit domain knowledge. So exemplar-based models will take us so far, but without the ability to actually constrain those models with some type of domain knowledge, we're going to have limitations. We're not going to be able to, for example, dictate what is a negative case. And so in things like medicine, we have seen that the introduction of domain knowledge has been useful in terms of increasing the ability to improve the efficiency of models and also the accuracy. This has also been done to a certain extent in earth sciences as well. It has not been done as much in the music domain. Domain knowledge includes both codified knowledge and also skilled practice. So there is the approach that I'm going to take with the rules, which I'll take from the textbook. I'll be as you'll see, first sort of like codifying those into things which can be done as first order logic rules and used to constrain models, but also skilled practice and the way, as I mentioned, that performers shape particular parts of the musical material can also be thought of as domain knowledge. And then the general thing which I'm assuming here or asserting is that the reduction of harmony to chord labels obscures the relationship between chords. And I'll talk a little bit about how this even comes into the type of metrics that we use in MIR. And so the fact that we kind of think about the idea that chords are just these things like it's a C or a G, or in the classical tradition that it's like a 1 or a 5, that we, unless we actually think about like what the notes are, that we're actually losing the ability to model those structural relationships between the chords. So that's the big overview, and hopefully as we go through the next couple of sections, it'll become clearer what all of those things actually mean. So taking a step back into modeling pedagogical knowledge. So most of you, I have no idea who exactly is in the room right now because I haven't looked at the chat, but some of you will have probably taken a music theory class at some point. Some of you may not. So I'm going to just start from basics and just say, what do music theories teach? And why might this be useful to take it, to teach it to a computer? So particularly in North America, the music theory curriculums tend to focus on the common practice period. This has been changing a little bit in recent years as there's been an attempt to broaden that curriculum to include music, which has been, which is more relevant to what students hear, also to diversify, to make it more representative. But still, it is largely true that there was a particular focus on the harmonic language of the classical era, both because this is considered a superior corpus for reasons which we can certainly discuss about, the sort of like great, myth of the of Western music and that superiority. But also there's been a practicality which has sort of entrenched this as well, right? Like, so this is part of the challenge in terms of diversifying the corpus in general, right? Like there was the large availability of notated music and a distillation of a harmonic language into pedagogical practice. And this is something, I'm going to say straight up, even influences my own research, right? Like I would love to be able to do this research on popular music as opposed to doing it on classical music. It is hard to do because of the availability of the textbooks, the availability of the notated work. And so what I am doing to kind of frame this is to say, I'm going to start doing this on Western art music and figure out ways to move it into a more representative music later on. And this is just, the way that I kind of have to move forward for practicality sense, while acknowledging that there is a problem in sort of focusing initially on this music because of the history there. So a large part of the pedagogical practice involves teaching students to parse structurally significant notes from the musical surface. Now, part of the challenge when you're teaching this, at least what I found, is that the students can become very obsessed, particularly because in North America, we tend to teach this like Roman numeral analysis, that the students just become like, oh, I'm going to put these chord labels down, these Roman numerals labels down. And that is just the end task, right? Like, did I get the label right? Okay, I learned exactly what I need to do. And that is not the task at all, right? Like the idea is to actually understand, what do these labels mean? How do these labels group together in terms of understanding how they fit together into phrases? And how do these phrases fit together into larger structures? If you're using like Bill Kaplan's approaches, like in terms of to things like periods and sentences and stuff like that. What sort of happened in a lot of computational approaches, which we see in like MIR, is that the computers are kind of stuck doing the same thing, right? They're like, oh, okay, we have a model and it's doing chord labeling, and that's the end of the task, right? Like, what is my F1 score now on having my computational model predict chord labels on this corpus? And there's no link between the prediction of those chord labels on, on the corpus for that task, and then the structure segmentation task. They're completely separate. And so it's really hard to then build any larger sense of musical understanding from that, because these are all separate tasks. And then what's even more challenging is that the way that the metrics for the chord labeling currently work is that they treat all of these chord labels as totally independent. So if you have a G and a G chord and you misestimate it as an F chord, you're going to get it completely wrong, as you should. But if you misestimate it as an E chord and you've got like two notes which are overlapping, you're going to get it completely wrong. But two notes are in common, right? So you would hope that you would be able to at least have some kind of nuance where you would at least get some kind of like, say, partial credit, right? Like if I was grading that, I would do that in terms of like, I would say, well, no, you actually, misunderstood something here, but you were kind of on the right track. So that's why later we'll see, the metrics are also important within this. So if the goal is to actually figure out which notes are significant, which notes are part of building part of the higher structure, it becomes a different task than just figuring out what the chord label is. So I have, a general hypothesis underlying this, which is it's not just chord progressions that are defining the style, in this case, Western art music, but this is also then true to pop music in terms of the idea of the spirit of keeping this to being a generalized model and not just about how do you model music from the Western tradition or the Western art music tradition. But it's the relationship between the chord tones and the non-chord tones. So I have a little quiz, which this works better when I give this type of talk in person. So I will just sort of like do this and leave it to you to kind of sort of like think about. And I won't actually get you to like do a survey or anything. So I'm going to play for you this this piece by this theme by Mozart, and then later I'm going to play for you a variation. So just kind of play this theme and then variation, then later on I'm going to play a different theme and variation and give you a little quiz on it. So to introduce you to the concept of a theme and variation, this is a theme by Mozart. So the first thing that we would like, ideally, to get the computer to do is to be able to parse this into 3 sections and to recognize that there are 3 closing sections here. So, and then in moving to the variation, for the first part of this, to be able to then recognize that there's actually different chords here, and that not only are there different chords, but there's also like an additional layer here, which is what you could call like the phrase layer, so that these chords actually have different functions. So the tonic, which establishes the tonal center, the predominant, which prepares for the arrival of the dominant, and the tension. And this particular phrase model I'm adapting from Steve Lates, who's a North American music theorist, but it kind of shows up in, it's derived from the whole history of different approaches, but this is the specific way he articulates it. So we also then can look at like a variation to the theme and see the chord progressions being expressed with a different musical texture. And then we'd want to be able to identify where the chord tones are there, and we see where the chord tones are and where the chord tones aren't. And so this is a fairly challenging task, right? And so the quiz that I'm asking you to now sort of do quietly by yourself is, what if we want to be able to then, given a theme, be able to match which variation goes to it? And the challenge here is to say, okay, are we going to match based on the details of the surface or the underlying harmonic progression? So here's the theme. And here's the first option. And here's the second. And in fact, it's actually the second. And the reason for that is because of the harmonic progression. But the thing that's challenging is that we see that in terms of the surface, in terms particularly of the meter, that the first one is actually more similar, but that particularly when you look at the cadence, with the fact that it's like a 5/1 cadence at the end, that is actually the second one, the second example, which is the one that is the matching harmonic progression. So this is the type of thing which I am sort of like aiming to have my model do in this particular thing. So my idea is that the theory textbooks are useful because they contain both prose and annotated examples. And so a while ago, I ran an experiment just predicting the function labels that I showed, the tonic, predominant, and dominant from the Roman numerals. And there was 18 rules that I worked on this with Dan Shanahan a few years ago, rules which were derived for diatonic harmony, and then 3 phrase level rules to ensure that this phrase model were adhered to. And the hypothesis was that a combination of the rules and the exemplar-based model would outperform either one in isolation. And so here's an example, well, a summary of the rules, and then here's an example of the way in which the phrase level rules would correct if there was, say, like a dominant prediction in the middle of the tonics. So that needed to be smoothed out. And this is just a textbook that we were using. And so you can see that when we were doing this with cross-validation on the textbook, it was not a huge amount of difference in the F score across the either the rules, the HMM with duration information included, or the combination. But when we started to look on the unseen data, and particularly for the predominant and dominant, when there was a lot fewer examples, that actually we did see that the combination of the rules and the exemplar-based model with the HMM did particularly outperform the exemplar-based model. So this was sort of like the basis of saying, okay, maybe this combination approach is something which would be useful in the future. And then the next stage in that was that I actually got some funding from Google, which I used to create the theme and variation Tavern dataset, which is available if anybody is interested in using it. And that is a kern-based dataset, which was expert annotated by 2 PhD level, each one was annotated by 2 PhD level music theorists. And it's Mozart and Beethoven theme and variation piano sets, 17 by Beethoven, 10 by Mozart, segmented by phrases. There was chord annotations and function annotations, and it's available on my GitHub, which I don't have a link for, but it's pretty easy to Google, or you can just email me if you can't find it. And so with that, I ran an experiment with Claire Arthur, who was one of the annotators and authors on the Tavern paper. And we were interested in seeing whether this idea about the chord tone, just looking at the chord tones, or looking at all of the representation. So if you took all of the notes, or just the chord tone notes and symbolic representations, or all of the chroma, or the chord chroma representations, would work better when doing similarity between figuring out with the dynamic time warping model if a theme and a variation match together. And it seems like that should be trivial, but it actually didn't always work all the time because of the amount of variations in the variations. So we did this matching, and we did find that in the score domain, it was actually, there was a slight improvement overall between matching between the notes and matching between the chroma, as we went from looking at finding which, like looking at taking the theme and matching it against all of the variations across the 5 theme and variations that we had. And then in the audio domain, we found that there was a greater difference across some of the themes and variations. So this at least provided an initial proof of concept that this idea of looking at just the chord tones was a useful way going forward. So these were the 2 kind of like seed things that that made this sort of like overall approach seem viable moving forward. And then finally, the last thing I just wanted to touch on in this part was the chord metrics, which I'd mentioned before. And this is current work that's under review with Christoph Weiss. And this is just a summary of the current chord metrics, which are in use right now. And you can see that only an old MyRex one, the one at the bottom, which has not even actually been used since for about 15 years, takes any consideration of pitch classes. Everything else is about the identity of the chord and treats the chord as independent. So what we've been working on is a pair of a pair of metrics, one of which is based on the way that things are formalized in natural language processing with insertions and deletions. And the idea there is to be able to identify how much the chords are overlapping, but also to penalize in case there are overestimates or underestimates. And then what we've done is we've formalized it both in terms of its relationship to the natural language processing approach, also in terms of how it relates to traditional true positives and true negatives and all that. And then we also formalized it so that it could be used in a vectorized approach, so that moving forward, if somebody were to use it, such as I'm going to be doing in the work I'm currently undertaking, it works well within this deep learning approach as well. And I can talk more about this if anybody's interested about it afterwards. One thing we did do as a small experiment with this is we actually looked at Tavern, and then we also looked at the data set that was put out by Coops and colleagues a few years ago, where they took the Billboard data set and added some additional annotators and looked at inter-annotator agreement to see how much root disagreement there was in those data sets. We found for Tavern that actually wasn't that much, but that there was a huge amount in Billboard, and that likely what's happening, particularly in pop music, is that there's a great deal of the error that is being found in these algorithms. There's actually, if you use different metrics, you'd be probably finding very different results across the algorithms. So metrics, although they're not the most exciting things to work on, are actually quite important. So that's my little plug for metric work. So then the second part of this is performance data. So I spent a long time working in various ways on this automatic music performance and analysis toolkit. This relates to a kind of separate part of my research, which is on the singing voice and the ways in which kind of the singing voice and intonation in particular relates to musical materials. But I've sort of now started to incorporate that into this work to see how not just intonation, but other performance parameters shape sort of like the expression of structural components in the musical surface. So one of the things which I spent a fair amount of time working on with my toolkit, it is a score-guided toolkit, right? So because I was working on singing, I was really concerned about being able to sort of find a way to deal with the signal processing problem of having a very messy signal. So I'm going to play for you one of the hardest signals which I deal with, which is 4 voices per part singing. And so one thing which I did develop a few years ago with Michael Mandel was a score-guided approach to be able, through alignment, to extract fundamental frequency and power estimates for all of the notes in these complexes. So here is at the bottom is a visualization, and you can see that by having the alignment, it's not just getting the individual voices, but it's also doing the segmentation as well. And because I'm using this within the context of having the score, because it's this Western art music context, I do have these scores, right? So this is part of the benefit of working within this domain. So I have the ability to get these FO estimates, to get these power estimates, and then from there, I'm able to produce these spectral representations from which I'm able to get timing, inter-onset intervals, perceived pitch, vibrato rate, and depth if need be, if it's looking at something which has those actual characteristics. Similarly, if there's jitter, fundamental frequency, slope, and curvature, which comes up particularly in the singing voice, perceived loudness, shimmer, also if it's a more flexible tone. Depending on whether or not it's a polyphonic or monophonic, I can get certain timbre descriptors. So if it is from the spectral representation, I can only get harmonic timbre descriptors. And if it's from a monophonic source, then I can get the full range. So this kind of list varies depending. So with the spectral representation, I'm of course only limited to those harmonic components. If I am using this on a monophonic source, then I can get any standard harmonic descriptor. But it does give me the ability to get a range of note-wise summaries. And then I also have developed some ways to actually encode these back into score data, both in terms of humdrum and then also in terms of MEI. So what I'm working on right now is integrating this in with the next stage of the computational model. And so in terms of putting it together, which is the current stage of the work, this is kind of the big vision, and I'm slowly plugging away at the first stages. So the idea is that there is symbolic training data and there is audio training data, and then these get aligned, and that there is the analysis which comes from existing corpora, such as my Tavern data set. There's a bunch of other data sets which are also available as well, which I'm eternally grateful for. There's also a range of music theory textbooks which have rules and also have more annotations. And then there's all of the various performances. And then these sort of all combine into a predictive model. And then the goal of this predictive model is to be able to take unseen musical note data, either in symbolic or audio form, and then to predict either notes in symbolic form or chord notes in symbolic form or chord chroma in the audio form. And the way that this looks in a practical sense, and this is the part that I'm working on right now, is the initial stage of this is to try and use some of the techniques which have been used, I mentioned in the medical domain, which is using first order rule logic rules on teacher-student models. And here, the pedagogical domain knowledge would be implemented, which has already been implemented in that earlier model as first logic rules. These would be implemented into the teacher-student model. And so once this is done, this model would then be put into a discriminator, into a GAN, and then that would then be used in order to generate more training data. And at that point, then the performance domain knowledge starts to get integrated into the generator to start to experiment with how much adding that in actually starts to improve the performance of the prediction. And so, as I mentioned, this is the beginning of the project. And so the current work right now is on the teacher-student training. So just to summarize, so as I mentioned before, the assumptions here are that humans learn with greater efficiency, and so then machines because of the domain knowledge. So I'm really interested in kind of systematically going through the codified knowledge that we have in textbooks and then the skilled practice that we have in musical performance to see how that can improve our ability to parse musical signals, starting in the Western art music domain. And I'm particularly working within this idea of chord labels. And I'm particularly interested in kind of addressing this issue of how harmony is not just these chord labels that we keep using, right? Like they're actually representative of what's really like a 12-element vector, right? Like if we sort of like think of the notes as being pitch classes, then our chord labels are actually a 12-element vector. And then that 12-element vector is actually a multi-class problem as opposed to the chord label being just a single class problem. And so that's the way I've sort of like operationalized moving this into how it's kind of like working within the sort of like deep learning model. And so again, I'm looking at the musical material and the performance element of musical style, leveraging the rich pedagogical tradition, and then also the way in which humans are actually like shaping the musical material when they perform it, and how we can actually extract that information and then model that. So this current iteration is on Western art music, taking advantage of music theory pedagogy, notated music and recordings, and integrating that through analysis and performance data. Moving forward, I think looking at popular music, it'd be interesting to see how lead sheets could possibly replace the notation, cover sheet or cover songs. There is, of course, music theory and pedagogy for popular music, and that is becoming, much more robust, which is useful. In terms of cover songs, I did run a workshop a few years ago for the Wimmer workshop at Izmir, and we actually went through the Covers 80 data set, and we sort of, a group of us sort of, everybody listed here, we kind of divided and conquered and sort of looked at like the commonalities in terms of the musical material versus performance. And overall, we did find that across the covers, the musical material was a lot more consistent than the performance, right? So it is, reasonable to think about using cover songs as using the musical material in cover songs as an invariant representation. And so that might be, although with some noise, a reasonable way of moving this project into the popular music domain. And then the final thing that I just wanted to kind of throw in here is that also one of the things I haven't dealt with are all this listener responses, right? So I'm really focusing on performance data and then expert analyses, but listener responses are another thing which are incredibly important as well. And adding that into this would, of course, make it a lot richer. A few years ago, I published a paper in TISMIR talking about how useful it would be to actually have, like, if not an integrated encoding format, actually just having encoding formats that allow you to actually encode this information in a way that allows you to like just transfer between this. And in the same way, I think, kind of thinking about how listener responses kind of would factor into this as well would be really useful going forward too. So I'd like to thank you for your attention and ask if anybody has any questions. Those are the references, which I can send to everybody if you want.
Do we have any questions? I'm trying to scan and I don't see. So while people are thinking, maybe I will ask a question. I think one of the kind of, I have a minor background in spending some time in American higher education. So I'm a tiny bit familiar with the pedagogy. And it is kind of this kind of identifying the structural nodes is kind of trickled down from Schenkerian analysis, more or less. Mm. And one thing that always slightly baffled me in this is that it's a kind of type of analysis where time doesn't matter. So the time, it's only about something that follows something that follows something, and it doesn't matter when does this happen in the piece. So it's a kind of musical analysis, or it's an analysis of music that detaches itself. The vocabulary, the method of analysis detaches time from music, which I think is a bizarre way of doing things in some way. So I'm wondering, does your thinking about this and the way you construct think about when things happen and not just what follows what?
Yeah, so that's separate from this school. So this is more like in the sort of the Bill Kaplan school of thought, which is very segmented. So it's sort of like you have a phrase, and a phrase is typically, it's very classical, right? So the phrase is typically like four measures, and then two full measure phrases will form a sentence. And then so it's actually and why I'm looking at these Mozart and early Beethoven is because it's more likely to fall into that. So I'm dealing with the convenience of very initially very structurally consistent phrase-oriented music, and that will become an issue later on. But it actually, the theories themselves, as you move into later, these theories, as you move later, are actually flexible expansions of that. And it's actually sort of the counter school to the Schenkerian approach.
We do have a request to
Sure.
to either show or share the list of references.
I can also see if I can post them in the chat. No, I can't. I can email them though.
Well, I mean, I presume Google Scholar will also give us a similar list. Do we have any other questions from anyone? I'm trying to see if anyone is any raised hands or. No. So I'll continue my inquiry. What do you think, I mean, about voice leading and the importance of, thinking about not only the succession of chords, but the way voice leading actually structures the music?
So one of the things I didn't get into, but sort of the next stage of when the GAN is sort of implemented is to start looking at attention mechanisms. And then to see how those could be used to actually then have more focus on specific behaviors. Because I do think that is actually an important thing, but I think that might actually come more so out of the data than the rules. That's my suspicion. Because I feel like a lot of the rules around that have a lot of exceptions. And that is actually something which the data may be more useful than the rules, or at least there would be an interplay that would be useful to explore.
Great. And we do have a question from Jeffrey.
Okay, I'm just going to stop the share on the things for a sec, but I can email them to you in case. Hi.
Hi. Thanks very much for that really interesting presentation. I was just wondering I was wondering if you could just describe a bit more the way that you're encoding your representations of chord sequences for ingestion into your deep learning models. And I guess the secondary question is I'm wondering to what extent you might have looked at using graph representations for these pieces. So, kind of representing different versions of a single piece of music using a graph. I found that you can, they're quite tolerant to discrepancy between, if it's a non-rigid piece, where maybe someone repeats a section or doesn't repeat a section, or there's an extra few bars here or there. Sometimes you can represent those graphs I found in it. It's a good tolerant way to do that. And I just wondered if you had looked at that, and if so, I'd be really interested in what you found out about that. Thanks.
So to be honest, right now I'm actually just encoding at the phrase level. So I haven't even gotten to full pieces yet. So the graphs would be a useful way to deal with that. So I'm actually this is part of why when I did the data set, I did everything at the phrase level, so I could actually just sidestep the full piece issue initially. So yeah, certainly that would be probably one of the things to definitely look at when dealing with the full piece. So right now I'm actually starting first with just the 12-element vector and not encoding root yet. And then the next stage will be having an additional piece of information for root, but I'm trying to kind of keep it as agnostic as possible to begin with, and then to put in additional information just to experiment with how much is actually learnable and how much is, you know, like how much you get from pitch class versus how much you actually need from the way in which it actually occurs within the score.
Mm.
So it's
And
kind of an experimentation process.
Okay. And have you, are you looking at like tonal interval vectors at all, or are you just looking at sort of straight up binary pitch class profiles?
That'll be the next stage.
Yeah. Okay, cool. Well, thanks very much for that. Yeah, I really enjoyed your talk. Are you going to be sharing the presentation around at all? There was a lot in there, and it'd be good to go over it again if that's possible, just to try and take it all in.
Yeah, I can definitely do that.
Oh, cool. Okay, well, thanks very much.
No problem.
Do we have any other questions? No. So I think we will all say a good day to Johanna and good evening to all of you who are on this side of the Atlantic. And thank you very much for joining for the first seminar. And we have another one in a month time with, I'm not sure who, but you can check our website and I'll send an email. Thank you very much for joining us. And thank you, Johanna, for an interesting talk.